So next we're going to do a really common example in Spark and MapReduce sort of books where we're going to count all the words in a text file and how many times each word occurs within that text. Now we're going to put a little bit of a twist on this because we're going to work our way up into doing more and more complex twists on that task. But the first thing we need to do is go over the difference again between map and Flatmap, because using Flatmap in Spark is going to be the key to doing this quickly and easily. So let's talk about that and actually jump into some code later on and see it in action. Okay, for the next few lectures, we're going to be looking at your standard count the words in a text file sample that you see in a lot of these sorts of courses, but we're going to do a little bit of a twist. So we're going to work our way up from a really simple implementation of counting the words and keep adding more and more stuff to make that even better as we go along. So to start off with, though, we need to review the concept of map versus Flatmap. And we've talked about this a little bit in the past, but in our examples so far, we've just been using map or map values to transform RDDs. So just to review, a map function will transform each element of an RDD into one new element. So there's always a one-to-one relationship between the RDD that you started with and the transformed RDD that you end with. So for example, if we had a text file that contained the quick red fox jumped over the lazy brown dogs, broken up on different lines like that, and then we wrote a mapper that has this lambda function that calls upper on each line that comes in to make everything uppercase, what we get back is exactly the same number of entries, just in uppercase. So again, we started with 4 lines and we end up with 4 lines. The only difference is that they've been transformed in some way. In this case, they've been all changed to uppercase letters all through. And if you're curious, that's a handy little sentence in the English language that actually includes every letter of the alphabet, if you've never seen that before. Now, in contrast, Flatmap has the ability to blow out an RDD into multiple entries, elements from each individual source one. So you can end up with an RDD that has more elements than you started with when you use Flatmap. So as an example, let's see how that works. Let's say that we load up that same text file in a lines RDD, and now we're going to call Flatmap on it, and our mapping function is going to be the split function. So what that's going to do is split up every line into individual words based on whitespace and output multiple results, one for each word. So x.split returns a list of words, and each item returned in that list from the mapper function will become an entry of its own in the new RDD. So the words RDD ends up containing each individual word as its own entry in the RDD, whereas we only started with 4 entries in the original RDD, one for each line. And that, breaking up text by words is actually a pretty common thing to be doing with Flatmap, and it's sort of the obvious thing to do with it. So with that, let's jump into the code and start with our simple example of word count. And in order to make it more interesting and real, I'm going to actually use the text of a real book. It's one that I wrote, so I have the rights to include it in this course. So let's go on and go to the resources for this lecture at this point and download both the book.txt file and the word count script, and we'll start playing with that right now. So again, if you haven't already, go to the resources for this lecture and download the word count Python script and the book.txt file, which contains the text of an entire book, and place it into your Spark course directory. Hit pause if you need to go take care of that right now. And when you're ready, double click on the word count.py script and we'll take a look at it. All right, very simple stuff, but the key point here is using Flatmap instead of map. So we're going to do all the typical boilerplate stuff to set up our word count Spark application. And we'll do our typical text file call on the Spark context to load up the text of the book one line at a time. And the way this is actually broken out, it ends up being about 1 paragraph per line. So that's a lot of words on each line, not very useful. Now, since we want to count up how many times each word occurs in the book, we need to bust that out by word, and that's where we're going to do our Flatmap function that will take every individual line of text, where a line represents a whole paragraph in our example, and our lambda function calls split, which just breaks that up based on whitespace into individual words, and it will put that list of words into the words RDD. And then we can very simply call count by value, which is a way to very easily and very quickly in Spark get a count of how many times each unique value occurs. So for every white space separated word in our book, we will get a count of how many times that word occurs. And we will get the results in the word counts list here. And this is just standard Python code here. There's nothing Spark specific about it. We're just going to go through every single word in our list of words. And this just takes care of some encoding issues. So in case something was encoded as UTF-8 or Unicode in our original text, this makes sure that we can display it okay on our terminal in our command prompt by converting it to ASCII format. So it also says that we're going to ignore any conversion errors that might occur in the process of trying to convert from Unicode to ASCII. So this is just a way to make sure that we can display these words without errors, even though they might contain special characters. Just a little Python trick for you there. And if that comes back successfully, we will print out each word and the number of times it occurred. So let's go ahead and run this. Spark-submit word count.py. Off it goes. Usual warnings. And that was pretty quick for an entire book. And there's some results. So, we can see, for example, the word extort only appeared once, the word kinds appeared 3 times, and the word other appeared 71 times in this book. But if you look at these results carefully, they're not entirely helpful. Now remember, we're only splitting based on white space here, so we're not really just getting words counted up here. We're getting all sorts of combinations of words with their punctuation underneath them. So web page, followed by a comma, followed by a comma, only counts as one word of itself. Click followed by a comma, that counts as a unique word as well. And here we have click followed by a quotation mark that also counts as its own unique word. And that's not what we want, right? Like, punctuation shouldn't count. Similarly, we also have uppercase and lowercase affecting things. So we have all uppercase leeches, which is probably part of some section of the book. And that would count as its own unique word compared to lowercase leeches. And again, that's not very helpful. We want to combine all of the words together that are the same word regardless of punctuation or capitalization. So we're going to have to improve on this a little bit. The other thing too is that these aren't displayed in a very helpful manner, right? Like, ideally we would want to get a list in sorted order, sorted by the most common words, so we could very quickly see what the least frequently used words are and the most frequently used words are without having to search through the entire thing. So we're going to build on this, like I said, and make this script even more useful. So let's take another round at it and try to improve on it in our next lecture. All right, we got some results there, but they're not that great. We still need to clean our data a little bit more, and we're going to do that next in our next lecture. So let's build upon this word count example and make it better.